Okay, number 4. Find the perpendicular bisector of a line segment whose endpoints are 10, -10, -3, and 9, -5. Okay, so let's plot the points. First, given. Okay, let's plot the points -10, -3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then -3, 1, 2, 3. Okay, so our first point is here. Okay, so this is -10, -3. When the second is 9, -5. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops. -5. Okay. I mentioned 10 before, so I have an excess of 1. Okay, so here. Okay, this point around here. Okay, so this one is 9, -5. And let's align it here. There. Okay, so let's draw the line from this point going to this point. Okay, mind if it's not really straight, I'm doing it freehand. Okay, oops, looks like anyway, this should be a line segment. Anyway, this should be we should not include this one. Okay, and so is this one. Okay, so a perpendicular bisector, okay, the one that we're looking for, is actually the line that passes through the midpoint of this line segment, okay, and is also perpendicular to the line segment at that point. Okay, so let's suppose it this is the midpoint. Okay, so this should be perpendicular. This is our perpendicular bisector. So this should this was accurate. This line should be perpendicular to this red line, or the line segment, and at the same time it passes through the midpoint. Okay, so it's not really a 90-degree, but anyway, this symbol here, since we drawn it freehand, okay, should indicate that this is actually 90 degrees. Anyway, okay, so required. Okay, let's label this one as our L. Oops. Okay, there's the label L. Okay, so required is of course the equation of the perpendicular bisector. Okay, so for our solution, so what we know about the perpendicular bisector is that it passes through the midpoint and is also perpendicular. So we get into the midpoint first. We need to identify the midpoint first. So that would be a point on that line, and then the slope. So if we get to know the slope of the line segment, then the perpendicular line has a negative reciprocal slope. Okay, so with that, if we can get those two, then we can use the point slope form of the line to get and then transform it into the general equation, and then we have our final answer. Okay, so let's start with our solution. Okay, so midpoint, okay, using the midpoint formula, so we just average the two endpoints of the line segment. So you have here -10 plus 9 over 2, and then on the y coordinate you have -3 minus 5 over 2. So our midpoint therefore is -10 plus 9 over 2, so that's -1/2. Okay, and then on the other side, that's -3 minus 5, that's -8 divided by 2, so that's -4. Okay, so we have our midpoint. Next is we get the slope of the line segment, M. Okay, so that's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So you have here negative 5 plus 3 all over 9 plus 10. Okay, so our slope therefore is equivalent to this one, negative 5 plus 3 is, okay, so this one is negative 2 over 19. So the slope of the perpendicular line therefore is 19 over 2. Okay, that's the negative reciprocal. So now we have a point on the perpendicular bisector, that's the midpoint, and its slope. Okay, so use the point slope form. Okay, so y plus 4 therefore is equivalent to 19 over 2 x plus 1 half. Okay, so let's simplify. Multiply both sides by 2, and while we're at it, distribute the 19. So you have 2y plus 8 is equivalent to 19x plus 19 over 2. I think we're gonna multiply this one further by 2 so that we can totally eliminate denominators. So you have here 4y plus 16 is equivalent to 38x plus 19. Okay, transposing everything to the right side, you have 38x minus 4y minus 16 plus 19, or simplifying and then reversing the left and the right side, you have 38x minus 4y plus 3 is equal to 0. Okay.